My name is Stuart Lynch, and in this video I'm going to be introducing you to the new observation framework that was introduced at WWDC 23. Now, the observation framework uses the new Observable macro, and that replaces the ObservableObject protocol along with the @published property wrappers. But I'm going to start back at the beginning and go over @state and @binding property wrappers that are applied to simple value types in your views. And then I'm going to go through how the @state object has now been replaced with a simple @state for objects as well, and how the observed object is now replaced with a bindable attribute. And then I'm going to finish by showing you how, if you want to add an object that is marked as observable into the environment, you'll replace the old EnvironmentObject property wrapper with the simple environment.
I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee.
Now, this is the third video that I've done now since the introduction of SwiftUI on data flow. And things have evolved and they're just getting better. I do have a starter project for this video, but it's really only a clean new project with an icon and a launch screen added. So you may just want to use your own blank project here, so long as you're using Xcode 15 or later. I will have a link to my project in the description as well as a link to the completed project too. And I really recommend that you work along with me. As I go through this example, you'll be able to gain a better understanding and have something to refer back to in the future should you want to implement the observation framework in your own projects.
Let's get started by creating two properties on our content view. The first is going to be a string for a name, and we'll never change this name once we've created it, so we can use a let to designate it as a constant, and I'm going to give it a default string value, and I'll use my name. The second will be an int representing some number, but we will be changing that value, so we'll need to designate it as a var and set a default value to 0. And since we're not using this outside of our view, both of these properties are marked as private. Now I'm going to replace the body content. Well, first I'm going to add some spacing of 20 to the VStack, and I'm going to remove the content of the VStack, but replace it with an HStack. For the first view, I'm going to create a text view displaying the local name using string interpolation and the string for the number. I'll follow that then with a button, but I'm going to leave the action empty for now. For the label, I'll create a text view using the string representation of that number. I'll set it to bold. And then I'm going to apply a bordered prominent button style and a tint of red. What we want to do for the action then is to generate a random integer between 0 and 9 and assign it to the number. That's pretty straightforward, but this generates an error saying that we cannot assign to property self because it's immutable. And this is because our view is a struct and we can't mutate properties directly within a struct. To solve this problem, we can annotate the number property with an @state property wrapper, like this. By doing so, we're indicating that the variable is the single source of truth for this value. SwiftUI then manages the property storage. When the value changes, SwiftUI updates the parts of the view hierarchy that depend on this value, namely the label for our button. So to access a state's underlying value, we can use the wrapValue property. However, as a shortcut, Swift enables you to access the wrapValue by referring directly to the state's instance, so we can simply use the same variable name to display its content. Now we can safely mutate that value in our action and our label changes. What I want to do next is to create a new property that's a Boolean property that will be able to toggle between true and false, and it will indicate our current state of happiness. Now, since this will change, we will need to use another state property wrapper, and we should again designate it as private as well. And let's assume that we are happy and give it a default value of true. Within the HStack then, we'll create a new view that's a toggle that will allow us to change our state of happiness. I can construct this using the string I am happy, and then the toggle is tied to the toggle view's isOn property, and we see that it requires what is known as a binding. Now, since toggle is a completely new and different SwiftUI view, we'll need to pass in our isHappy property so that we can let it manage the state of change. If I just use the isHappy property here, this is the wrap value, and I get an error here. We'll need to designate this dependency as a binding by prefacing it with a $sign. Now we can both toggle the I am happy status and generate a new random integer between 0 and 9. In that first example, the view owns the values of all three of our properties. This is fine for our simple view, but it's not necessarily efficient if we want to be able to use these three properties elsewhere and keep them all tied together as a property of some greater object. So let's try that. Create a new file and call it user. Within that file, create a new class with the same name. Inside the class, then, we'll create three properties, as we'll be accessing the values of these from one of our views, but we're not going to assign any default values here because we'll do that when we create our instance. This does create an error, however, indicating that the class has no initializers. Now, when we create an instance of the user object, we'll be providing a default name and number, but we'll want to assume that the initial state for everyone will be that they are happy. So I want to eventually set that to be true for everyone upon creation. Now, creating an initializer is easy because all we need to do is to start with the word init, and Xcode will complete it for us. I said that I want isHappy to be set to true by default, but I also want the ability to set it to be false upon creation for those poor people who are not happy when I create the instance of them. So we can set our initial value to true right here in the init's parameters. Back in our content view, then, we'll create a private variable called user that will be an instance of our user type. And you can see that we have two initializers. One that accepts the default value for isHappy, and the other one will just allow me to provide false if I wanted to. Let's accept the first default and create a user with the name Emily this time, and provide a number that is 10. What we want to do now is to modify that number and the isHappy state of our user, just as we did for the state properties of our first example. Since the name is a let in the class, we will not be able to modify it. We'll need to go back to our class now, though, and tell it that we want to be able to mutate those properties. Prior to Xcode 15, we needed to indicate that our class conformed to the ObservableObject protocol. And those properties that we wanted to mutate, we would annotate them with the @published property wrapper, like this. Well, in Xcode 15, this has changed with the introduction of the observation framework. We no longer conform to the ObservableObject protocol, nor use the @published attribute or property wrapper. Instead, we import observation. And then we use the new @observable macro to designate this class and its variables to be observed properties. We don't need to do anything else. Macros were introduced in Xcode 15, and what they do behind the scenes is modify your code at compile time. And you can see this if you right-click on the macro and choose Expand Macro. There's a lot of code here, but fortunately you don't, at this point, need to understand what is going on. Basically, this is switching the property observation from the previous publisher and combined framework to the newest SwiftUI APIs. So we'll right-click back on that macro again to hide the expansion. Back in our content view, then, we'll need to indicate that our user has to be observed for changes in any of its properties. And prior to Xcode 15, we were using the ObservableObject protocol, and we would have used @state object when we created our instance. Well, now it's even simpler. We just use the same @state as we did in our other properties. So let's create another set of views within our VStack that will allow us to use this object. So I'll collapse that first HStack so we can isolate our thoughts here. I'll create a new HStack below it within the VStack. I'm going to do it a little differently here by creating a menu this time. And it's going to display the user's name, but also allow us to display a number that they can select from between 10 and 19. So I'm going to use the menu title key content initializer. For the title key, we can use string interpolation to display both the user's name and the user number that we'll be selecting as a string. And then for the content, we can use a for each loop to loop through 10 up to but not including 20. And that we can use to provide us with a variable that we'll call num. And we can use that num within the for each loop to create a button that will display the number as a string. And then when selected, we'll set the user's number property to that value. And then for the entire menu, we can set the button styles to bordered prominent and then apply a tint of green. And you see that by selecting the menu and choosing a number, it updates the number in the label. Let's also add that toggle to change the user's happy state. I'm going to use a very similar one to the previous view, where I'll need to use the toggle view, where the label is I am happy, and it has to be bound to the user is happy property. And notice that we are really binding to the entire user state property and the is happy property within. So the $sign goes in front of the entire property, not just is happy. We currently have two views in our VStack, and each one is an HStack. Well, let's create a new view inside our project, and I'm going to call it with children view. And then I'm going to go back to content view and copy those same four properties. I'm going to paste them into this view. These are entirely new properties, and they're not at all connected to the exact same properties in the first view. So just to keep things straight, I'm going to provide a different name for the name property and for the user's name. Then I'm going to return back to content view and copy the entire VStack. And then go back and paste that in, replacing the text view in our new view. Now, if the preview doesn't refresh for you, simply just comment it out and then uncomment it again. This seems to be a bit of a quirk that might be fixed in the version of Xcode that you're viewing. But so far, nothing has changed in this view other than the names. What I want to do is to factor out these two HStacks into independent views and use injection to pass in the relevant properties. Now, normally I'd do these different views in a separate file, but for demonstration purposes, let me just keep those views here in this file so we can easily see what's going on. So below and outside of this struct, I'm going to create a new SwiftUI view that I'm going to call HStack1View and allow Xcode to make the code completion to provide me with the body property. And then I'll cut out the entire HStack from my VStack and use it as the body. Now the body has no idea what name, number, and is happy are, as it doesn't know anything about those properties. We want to inject them into this new view when we create our HStack. Well, like our first view, name will not be changing, so we can create it as a let, but not give it any value. This will get passed in when we create it in the parent view. So we can't make it private. Structs have member-wise initializers, so there's no need to create an initializer here like we did in our class. Number will be changing, however, but it's coming from our parent view, so we can't annotate it with an @state property wrapper because that's restricted to only the parent or those that own that particular property. Well, we do want to update it, however, so we'll use binding instead. And this means that we don't have to provide a default value, but we do when we create an instance of our view. And this is also the case for isHappy. In this case, we'll be passing in the isHappy property from our parent view, and the toggle view is quite happy to bind itself to a binding as well as the state property. It just passes along the value through each view hierarchy. Now we can return to where we cut our HStack and create an instance of HStack1, and we see that it is requiring us to provide those three properties. Name, which is a simple string that will not change, but the other two values must be bound to state properties if we want them to update. And that, as we saw with the toggle, we do this by using a $sign. Testing now, we see that it's working exactly the same way. So let's do the same for our second HStack by creating a new HStack2 view that is of type view, and Xcode again provides us with the body. And then we'll cut out that HStack from the parent view and paste it in as the body. As with the previous example, errors are showing because it has no idea what this user object is and these three properties. Well, we could simply just create three properties as we did before, and I'll just copy and paste them in here. But I'd have to remove the user designation from each one of the different properties that are being accessed here within our HStack. And then when we create in the HStack2 view instance, we'll pass in those specific values. And making sure that we use a $sign in front of the actual object anytime we need to make changes or binding. Well, this works as you see, and in fact, if your child view is not using all of the properties of your parent object, this is how you can do it. However, our child view is using all of the properties, so why not pass in the entire object and bind to it? So let's go to that HStack2 view, remove those properties, and create a new property called user that'll be of type user. So now we'll have to add back those user object attributes. Now I said we could use binding, but binding should only be limited to non-custom values like a string or an int. In our case, user is our own custom value type. So instead of binding, we'll use bindable. If you use binding, you may find that you're going to run into problems later on in your code. When we used a state object in our Xcode 15, our child views used observed object. Now that we're using @state for both custom and non-custom value types, we use a binding for a simple data type and @bindable for custom ones. Now when we create the view, all we need to do is to pass in our user as a bindable object. But you'll notice here that unlike when we used a state object and observed object, for state and binding, the bindable object does not require that we preface our injected property with a $sign. If we test now, we see it's all working as expected. There's one more property wrapper that's been deprecated and replaced with something simpler, and that's the environment object. Prior to Xcode 15, we could create an object and inject it into the environment for all our views to access without having to pass it in like we did just in that previous example. The environment object, though, has gone away and has been replaced with the currently used environment. Let me show you. Let's create a new file and call it app_state. Inside that, we'll create a new class with the same name. So let's import the observation framework here once more and apply the observable macro to this class. Now we can create properties in this class that we can observe and inject the entire instance of this into the environment when we start the app up. So let's just create one property in here, and I'll call it isLoggedIn as a Boolean variable. We either need to create an initializer for this so that we can set the property when we create the instance like we did with our user, or we can simply provide a default value here without an initializer. Let me just create a default value here and set it to false. Now we need to create an instance of this and inject it into the environment, as I said. And we'll do that in the app start location where app main is located. And we'll create an instance of app state as a state property because we want to observe changes. And then when we present our content view, we're going to inject this into the environment so that views that want access to it can have access to it. So let's see how we can put this to use. And I'm going to do that by creating another SwiftUI view. And this view, I'm going to call it Start Tab View because I want to present both of my views in a tab view. So we'll need two tabs. And the first tab was going to be Content View. And for its tab item, we'll use an image with the system name 1.circle.fill. And for the label, I'll just use a text view with the string screen1. And then I can simply just copy and paste this for my second tab view, but it is going to be pointing to with children view. And for the image, I'll use 2.circle.fill, and the label will simply be screen2. Now this is going to be my new start screen. So I'll need to go back to the app start location and change content view to the start tab view. So we've injected into the environment our new app state, but I'll need now to return to the start tab view. And if I want to have access to that, I'll need to create an environment object. But we no longer use the environment object property wrapper. Instead, we'll simply use @environment, and instead of providing a key path to something, we simply provide the type of object that we want access to, and that will be an app state object. So we'll need to specify self so that we can access that type, and assign it to a variable that I'll simply call app state. And this causes our preview to crash. So we'll need to inject an instance into our environment here, just as we did in the app startup, where we'll specify the environment and provide a new instance of app state. Let me also now embed our entire tab view inside a navigation stack so that we can add a title and a toolbar. For the navigation title, I'm just going to use the string observation. Now we can create a toolbar. And for the toolbar item to go up there in our navigation bar, I'm simply going to create another toggle that will toggle between logged in and logged out. So for the label, I'm going to use a ternary operator here so that if the app state.isLoggedIn property is true, then I'm going to use the string logout. Otherwise, I'll use login. So that's our label. And since our app state is an object that's been marked as observable, we should be able to, as we did with the user object in our second view, bind it to the app state logged in property using a $sign. When we do this, however, I get an error saying that I can't find that app state in scope with a $sign. Now, I think that we should be able to use this, and that this is an error because our app state is an observable object. And I've reported this as a feedback to Apple. And if you're getting no error here, then that's great. You can just ignore this next couple of minutes here. But if it's still giving you an error, then this is what you have to do to resolve it. Within the body of this view, I have to create a bindable property, @bindable, and call it app state. And that's going to be local to this view, but I'm going to assign it the value of our environment object. so that it's going to be bound to that, and any changes will update that environment object as well. So now when I view this, I can toggle between the two states. Now I know this isn't a particularly good example for a login and logout button, since a toolbar does something strange with the display of a toggle. But I did this on purpose because I wanted to show you how using a view with a binding to an environment object requires that extra step that I just showed. If I'd used a regular button to toggle this state, I wouldn't have had to add that app bindable property. Anyway, just to finish this off now, then let's also use that app state in our two other views. So in order to access that app state instance, we'll need to use that same environment access that we have here in each of our two views. And then to fix the preview issue in each case, we'll inject an instance into the environment. So now I've got access to that isLoggedIn property that's coming from the environment. And as long as we're just accessing properties from our environment object, there's no need to access them as a binding. So for example, in Content View, I can surround the VStack with an if clause and display the content only if the app state is logged in is true. So our view disappears because the default is false. However, I can add an else clause here and then use the new Xcode 15 content unavailable view in SwiftUI to display a login string message along with a system image using the system image lock.fill. And then I can do exactly the same with our children view. I'm going to run this in the simulator. When we launch the app state's isLoggedIn property is false by default, and there is no content visible on either tab except for that content unavailable view. However, if I tap the login button in the toolbar, it appears on both of our tabs, and I can modify content on each of those two tabs. If I tap the logout button, the views are made unavailable once more. If I tap login again, my views return, and those previous values that we set are still intact. So it's important that you understand the new observation framework and the observable macro. So I hope this video has given you enough of an understanding of how to implement it and how you might go about updating your existing projects to use this and migrate from the observable object protocol and the old state object, observed object, environment object, and published property wrappers. This is the way going forward, and all of my future videos are going to be using this. If you enjoyed this video, please give it a thumbs up and leave me a comment. Be sure to subscribe to my channel and ring that bell to get notified of new videos as they're released. Thanks for watching.